welcome back to my YouTube channel. In this video, I'm going to show you on Form 4 Physics Chapter 2 Force and Motion Part 4, where I'm going to talk about force, impulses, and resultant force. So let me jot it down. Form 4 Physics Chapter 2 Part 4. Okay, so first of all, I would like to recap what I've gone through in the previous video. It's actually related. Now previously we have force, we talk about inertia, we have talked momentum, whereby inertia is relates to mass. Higher the mass, higher the inertia. So here, this chapter, we talk about force. When it comes to force, this will be the first time, symbol F, force. The mathematical equation that relates mass and acceleration found by Newton. Okay, where F equals to ma, the unit for force, called a special unit, is called Newton. Okay, special unit, derived quantities, or is equivalent to kg, meter per second per second. Okay, now what do you learn from here? It is you go through your reference textbook later. Force, you have quite lots of effect on force. Say for example, plastic ruler, you can bend it when the force is exerted on both ends. Or maybe the shape of a tube of a toothpaste change when you press on it. Okay, or a car, you push on it. Okay, to change the direction, original direction, the car initially not moving, you give it a push and start moving forward. So that's the effect of it. So doesn't need to go through how the effect of it. You may go through your reference or your textbook. What we'll go to is you want to look into what's the effect. Okay, look for the effect of it. Okay, look for the effect from your reference or text. You need your reference. Okay, effect of shape. Normally it's deform, or the change. Normally also the change in the state, the change of state. It will cause a change of the original state, maybe in terms of shape or in terms of direction. Okay, so these are the effects. So based on the equation, mathematical equation, F equals to ma. Okay, so what do you get from here? In inertia, we talk about first law of Newton. Okay, change of state, mass, higher the inertia. So an object stay in its position unless there's an external force on it. So that's first law. Here, whenever this equation is involved, you talk about second law. Okay, about second law. What is the second law? It says acceleration. Here is acceleration. I think we have gone through it previous video. Acceleration of object from this equation, you can see acceleration of object is directly proportional. I hope you know what does it mean by now, because chapter 1 I've gone through it. The graph, okay, is directly proportional directly proportional to the net force. So second law is all about this equation, and inversely to the mass. So how do you remember it? You doesn't need to remember it, because what happened, those wording is actually from the equation. So you want to talk about acceleration, force and acceleration. So from this equation, so therefore my acceleration is actually F over a m. Okay, So therefore, the force acceleration is direct proportional to F and inversely to the mass. That's all about it. Okay. Then in some objective question, they will say, what if I have 1 Newton? What does it mean I have 1 Newton? 1 Newton meaning you have a mass of 1 kg, with an acceleration 1 meter per second squared. That's all about it, because it's direct application to the force equals to ma. Okay. Then this is second law. That's all about it. Then it comes to impulses. Now, how you come to apply the impulse and force of impulse? Now, so actually, from this equation, if you look into it carefully, F equals to ma is related to my previous video. Mass is a mass of an object. It wouldn't change. Okay. It's about the number of matters in an object, so it wouldn't change. What changes is acceleration. So therefore, you may rewrite this equation as m from our previous video is v minus u final minus initial over the change of time. I think you may want to look for my previous video on how to get acceleration. Oh, okay, mistakenly. Okay, so if you look at this equation carefully, what happened is, therefore the net force, therefore this is the net force. The net force is actually direct proportional, or is proportional to, now if you do the maths right, you times m into it, what happened? That will be mv minus mu over t. What you see from here is actually the net force is direct proportional to something over time. This is, it means it is a rate of change of mass velocity. That would be change of momentum. Yes, I've gone through this in my previous video, so those videos, they are actually related. Okay, you need to go back to my part 3. What does it mean by momentum? What does it mean by acceleration? Alright, so you may put it in that way, and if you relate force with change of momentum, then we relate it to this net force. There's another name, they name it as impulsive force. Impulsive force, you relate impulsive force to the rate change of momentum. Now, where do you use it? Now, if you look at this equation carefully, what happened is the momentum force, what happened when the time t increases, what happened to the force? The force reduces. Meaning if the collision, now because momentum is all about collision from our previous video, so if the collision time, or you call it impact time, or the impact time, if the impact time increases, what happened? The impact force reduces. So that's why you need to have a bumper in your car. When you use it, when you have a car, the bumper helps to increase the collision time, so that the impact force will be reduced. Don't be surprised if you manage, to go to a workshop to open up a bumper. You'll be surprised what you will see inside there. They will have styrofoam. Okay, you have styrofoam inside the bumper. It meant to increase the collision time. Now you may look into your textbook reference on how do they make use of this effect in reducing car accident, injury from car accident. Okay, on an impulsive force. One way is have a bumper with styrofoam. There is a styrofoam. Trust me, I've seen it myself. Also, seat belt, okay, airbag, okay. Those are the example, okay. Say for example, reducing where you can find it. You can in a car for airbag, meant to reduce impact force. You have bumper implanted with implant, embedded, meaning implant with styrofoam, STRYFORM, I think. Nah, styrofoam, STYFORM, I think. Now I can't be sure for the spelling. Look for styrofoam, okay. Airbag, bumper, and a seat belt. That's why it's good, always advised to wear a seat belt whether you are sitting front or at the back. Okay. So there's a few examples. There are a few more examples from in your book. Okay. You may want to look into it. Now, so this is about impulsive force. Now, with this equation, mathematically, you may change it this form as to another form where you bring up the t, so therefore Ft equals to mv minus mu. So if you bring up the t, what happened? The product of force and with the time, this product, you get another name for this. They call it as impulse. We define is a product of force and time. We define is, I mean, in terms of words, is actually a change. This is a change, isn't it? A change in momentum. Where do you apply this? If you played tennis or squash or any ball earlier, in my example, earlier video, okay, when a ball smash into a wall, it bounce back, okay, V. So there would be a change. So you need to have the third law that's applied, where the third law comes in, okay. In order for the ball to bounce, equal and opposite force need to apply onto it. Okay, so the force from the wall to the ball and the ball to the wall. In order for the ball to move to the left, so meaning the force, there are two. One is from the ball to the wall and the wall to the ball. So equal and opposite direction, magnitude. Okay, so a change in momentum is actually Ft. The rate change of momentum, they call it impulsive force. Alright. So you may look through the example from our text. Maybe you want to pause this video and look for what's the mass, what's the acceleration. It's pretty straightforward. Maybe I'll give you an example. If I can find any hard one. Well, you have an object. Example. Object moving. Exert a force to the right. And force is a vector quantity, 1 Newton, 1 kg. And this object will say to accelerate at 1 meter per second, then, or put it the other way, 1 Newton, maybe 5 kg. What's the acceleration? So pretty straightforward, because F equals to ma, mass A. So therefore my acceleration will be force by m. It's always it is important that always you need to write down the equation. Then you need to find out what do the question ask. So this is what they ask. Then only you apply. I mean, you substitute the number. oh, the other way around. Okay, force is 1 Newton over 5. Acceleration is meter per second per second. Okay. So that's basically how do you want to use it. There are some harder questions. They give you other information. Look for acceleration. You may try, maybe 1 week time, try 8 to 10 questions on this. Only then you'll be able to excel this kind of questions. Alright. Then once you have this in mind, then next that would be called before we get into resultant force, let me introduce you a new term. It's called balanced force. Before we go into resultant force, because if it doesn't know what does it mean by balanced force or unbalanced force, then that's very hard. Balanced force, all forces. Now, just for you to understand, okay? In the event where you have a balanced force, meaning left and right is the same, otherwise you wouldn't say it's balanced. Unbalanced, meaning either side, you have an extra force pushing it. Right? Say for example, what does it mean by balanced force? Okay. The easiest most example would be there's a wall and you were seen to push against the wall. Okay? You feel it. You need to feel the force. In this chapter, you need to feel it. How do you feel it? Now, if you were pushing the wall, okay, so there's definitely one from you to the right. Well, don't forget, while you are pushing it, there would be another force. You feel like there's another force pushing against you. Okay, now look at this arrow carefully. You study carefully. What happened is the length is remain the same. It's just that the direction changes. Okay, the length is the same. The length of this arrow is the same, meaning they are of equal value, opposite direction. Okay. All right. So which one is my action? So this is my action. This is what I name as action force. Action force. What about the yellow one? Or what do you call it? A beige or orange. And this is called the reaction force. Action and reaction force. Okay? Equal and opposite direction. So that's what, from balance law, I want to bring out what the Newton third law says. Okay, that's the Newton third law. Actually, Newton third law comes out earlier in my previous video on the explosion. Left and right the same. Yeah? Newton third law of motion. What it says? In every mode action, meaning in every action, what happened? There is an equal, from the diagram, yeah, from the diagram, there's an equal but opposite reaction force. That's the law. Okay, you push it in, then it's gonna come back to you. And this is also what you will see from the impulse, rate change of momentum. It's related. Okay, then If you know about balanced force, then how about unbalanced force? Can you give an example of unbalanced force? It is important because here, balanced force, the left and right, they are the same. Okay, you may pause this video. And give a look at the questions. See if you have anything you miss out. If you come back with here with me, then I'm going to introduce you the next term called unbalanced force. Now, as for unbalanced force, the concept would be like a car drifting forward. A car. Okay. From rest, and then it start to move to the front. Okay. So what happened? What are the force from a free body diagram? The force act on it. Okay, would be first the gravity force, meaning you give your weight, and also force and reaction force, normal force, and going up. Do not confuse N with Newton. The symbol here is normal force, meaning put against the weight against the gravity going upwards. Okay. Then what happened? If the car was seen to move forward, V constant. Now what happened with V constant? If V is constant, therefore there's no acceleration. Okay. Now, if you're moving constant, what happened? You're going to have resistance from the air, isn't it? Air drag. From the air drag is a resistance, isn't it? If moving to the right, then the resistance is to the left, going against it. Well, at the same time, the tire and the wall and the road, they're going to have resistance, a frictional force. Trying to label all the force. Yeah? Whenever you see a diagram, you need to learn how to label force. At the same time, next week you get the overall, the engine of the car, giving it a thrust to the front, right? Okay. So that's all the force act on the object. Now, it will say unbalanced because it's always, well, if it's a constant, then it is unbalanced because it's this car moving to the front. So meaning here the normal force balance with the weight. So therefore this car is not moving up or down, but is moving to the right. So therefore your T should be at least or greater than the drag force from the air. Maybe I'll call it a drag force from the air, and the frictional force, F. Okay. Now if it were to be constant, then therefore that's equal, right? So therefore should be equal to, because if it's constant, acceleration is equal to 0. Right? If it's constant, then equals 0. If you have acceleration, then there's some value to find out. Okay, I'll go more into it, but at least you know that a balanced force. If it's at constant, then the T to the front is equals to what you have dragging it behind. Okay? When you have acceleration A, then that will be another story altogether. Okay, that will lead me to the next video, pulley system. Okay, let's not go into that yet, because you have learned balanced force, unbalanced force. Next thing comes out would be called the resultant force. Now, resultant force is a phenomenon. It's not a condition, it's a phenomenon. What happened? How do you define that? Okay, balanced force, unbalanced force, resultant force. What is resultant force? Okay, resultant force by definition, result, right? From the word result, meaning is a single force. It's a single force. It's a single force that produce the same effect. As the combined, meaning you have a few force act on it as the combined force. Okay, meaning, let me give you an example. Now, if you were to have an object, you may try at home. From a top view, you give it a pull over the right, says 90 Newton, maybe. Give it a push at the same time, going up, says maybe 70 Newton. Where do you think this object would be moving? Maybe I will talk M. Will it go to the right only, or will it be going up only? You'll be surprised, because this object neither move to the left, move to the right, nor going up, but it will be moving in this direction. Okay, so this is what it means by the resultant force. Resultant R, maybe. And this resultant force could be calculated by using theorem Pythagoras. How can you do that? How can you do would be, here I'm moving over to this side. How do I get the FR? Now all you need to do is transfer. Yeah, you need to do is first bring this force 90 Newton. Well, 90 Newton should be longer because it's 90, I would say. And then you connect tip to toe. Okay, this is the tip of the arrow. Connect to the toe. 70 should be short, slightly shorter than 90 Newton. Okay, so the arrow points to the tail. Okay, tip to tail. Then what happened? The resultant, all you need to do is you connect tip to toe, here to here. Okay, so it's like you start from here, you walk to the right, and then walk up. Where you end up here. So it's the direction is from here to here. So this is resultant force. And always look for the angle. Okay, what's the angle from the horizon or the horizontal theta? To do that easily, right? I think you can know it because Pythagoras says is 90 squared plus 70 squared. Pythagoras theorem. So therefore, my resultant force would be what? Do it correctly, then it would be somewhere 114 Newton. And the angle, you need to find out angle because force is quantity, is vector quantity. So therefore, it will be equals to arctangent. Make sure the mode in your calculator is tuned to degree. It will be 70 over 90. So therefore, the angle will be 37.9 degree. Okay. So this is how you get the resultant force. First, you need to identify where you will be moving. Then look for where you will be going. Here, right? Then the arrow to the tip, to the toe, to the end. Connect them, and then connect all of them. Okay. I think I will make another video for this, but if I were you, you want to stop this video and try for questions on resultant force. Now we are just horizontal and vertical. You're not talking about an angle, okay? I think my next video, I'll do more specifically on resultant force. With that, I would like to end this video so that you have time to read on your reference, at the same time to try on questions. At least to have about, this one I would say is you need about 15 questions over 1 week time, so that you are good at what have gone through in this video. With that, stay tuned to my next video.